In this lesson, we're going to dive into consuming a RESTful API from another Spring Boot application using Feign Client. We'll create a Spring Boot application that consumes the football RESTful API, which we built earlier, and along the way, we'll learn how Feign Client simplifies the process of making REST calls. Now, just to refresh our memories, so far, we've talked about effective error management in a Spring Boot RESTful API, stressing the importance of custom exceptions and global exception handlers for structured error responses. We've covered how to implement meaningful HTTP status codes and highlighted the significance of logging errors to enhance oversight of our applications. Plus, we discussed the necessity of having a uniform JSON error response structure to improve client interaction with the API. Now, as we look ahead, in our next lesson, we'll focus on testing our error handling mechanisms to ensure they perform correctly under various scenarios.
Now, let's implement the necessary dependencies in our Maven pom.xml file for a Spring Boot application that uses Feign Client. We start by defining the required dependencies under the Dependencies section. This includes the Spring Boot Starter Web for building web applications and the Spring Cloud Starter Open Feign to enable Feign in our project. And don't forget the Spring Boot Starter Dev Tools. This one is great for enhancing our development experience with those nifty live reload capabilities. Now, keep in mind, the Spring Boot Starter Dev Tools is marked as optional and is only needed in the runtime scope, so you won't always have to stress about it. Next, we have to ensure that the Spring Cloud dependencies are available. To do that, we'll add a repository section where we specify the Spring Cloud repository URL. This step is pretty crucial because it allows Maven to fetch the necessary artifacts for the Spring Cloud components used alongside Spring Boot, ensuring we get that smooth integration we're looking for. By setting up these dependencies correctly, we're paving the way for utilizing Feign Client in the later sections of our application. It's going to significantly simplify our interaction with the football RESTful API, you know? This is a crucial step that lays the foundation for a seamless API consumption experience.
We start by importing the necessary Spring Boot libraries, including Spring Application, Spring Boot Application, and Enable Feign clients. The @Spring Boot Application annotation signifies that this class is the entry point of the Spring Boot application, while the @Enable Feign clients annotation activates Feign clients. This means our application will automatically scan for interfaces annotated with Feign Client, allowing us to easily define and communicate with RESTful services without all that boilerplate code. Now, inside the class, we have the main method, which serves as the standard entry point for Java applications. This method calls springapplication.run to launch our application. By using this setup, we are laying the groundwork for interacting with the football RESTful API we intend to consume. Next, we're ready to create a Feign client that will facilitate our communication with the API, streamlining our ability to fetch data such as match information from the football API in a structured way. Now, let's implement a Feign client to interact with our football RESTful API. Here, we create an interface named Football API Client and annotate it with @Feign client. This annotation registers the interface as a Feign client, where the name attribute specifies the client's identifier, while the URL attribute points to the API's base URL. Now, we need to define the API call we want to make. By using the @getMapping annotation, we specify that we want to fetch a list of match details from the endpoint /matches. The method getMatches is declared to return a list of match DTO objects, which will serve as our data transfer object to capture the details of these thrilling football matches. Next, we're going to create the match DTO class. This class will consist of properties including ID, home team, away team, and score. It encapsulates the match information we wish to retrieve from the API. Each property has its corresponding getters and setters to facilitate data access and manipulation. With this setup, we are poised to interact with our football API and effectively retrieve match details in our Spring Boot application.
This service is marked with the football service annotation, indicating that it's a Spring-managed component responsible for business logic. Within this class, we'll declare a private final field for the Football API client, allowing us to utilize its methods for making API calls. Next, we will define a constructor for Football service, where we'll use @autoed to inject an instance of Football API client. This dependency injection ensures that our service has access to the necessary client without needing to create it manually, promoting good design practices and vastly improving testability. Now, let's create a method called fetchMatches. This method will be responsible for invoking the getMatches method from the Football API client, which communicates with the external Football API. It returns a list of match DTO objects, a data transfer object that encapsulates all match details. By structuring our code this way, we maintain a clean separation of concerns, allowing our controller to focus solely on handling incoming requests while delegating the data fetching logic to the service layer.
This is done by creating a class named FootballController, which we'll annotate with @RESTController. This annotation signifies that our controller will handle RESTful responses. Next, we're going to define a private variable for the football service that we'll use to fetch match data. To enable dependency injection for the service, we'll utilize the @AutoWired annotation in the constructor. This way, when our controller is instantiated, an instance of football service is automatically provided to it. Now, the main functionality resides in the getMatches method. By supporting HTTP GET requests at the /API/matches endpoint, this method calls the fetchMatches method from our service layer. It expects to receive a list of match DTO objects, which represent the details of the football matches. And by returning this list directly, we leverage Spring's ability to automatically convert the data into JSON format for the client. This simplicity in returning structured data is one of the key benefits of using Spring Boot's REST capabilities. At this stage, we are not only fetching data from the service, but also simplifying the communication process between our application and external APIs, all while keeping our code clean and efficient.
Let's dive into implementing an effective global exception handler to manage errors across our application. We're going to focus on the Global Exception Handler class, which we've annotated with @ControllerAdvice. What this means is, it's set up to handle exceptions thrown by any controller throughout the application globally. This design choice really helps us centralize our error handling logic, which leads to much cleaner and more maintainable code. Now, within this class, we're going to define a method that's annotated with @ExceptionHandler, and it specifically targets exception.class. So any exception that bubbles up, like a pesky little balloon, will be intercepted by this method. When an exception occurs, this method constructs a response entity. It includes an error message along with the appropriate HTTP status code. In our case, we're setting that to 500, indicating an internal server error. By returning a user-friendly message that incorporates the actual exceptions message, we're enhancing our client's understanding about what went wrong, rather than, allowing the application to crash ungracefully. This implementation is smart. It not only guards against unexpected breaks, but also creates a coherent way to inform clients about errors, all while integrating seamlessly with the overall structure of our Spring Boot application.
As we wrap up, consuming a RESTful API using Feign client in a Spring Boot application is, a really powerful approach. The integration is seamless. It allows developers to really focus on writing business logic instead of getting bogged down by boilerplate code. With just a few simple annotations and interfaces, we made a call to an external API and returned data to our users. So, in this lesson, we journeyed from setting up dependencies to creating a working application that fetches data from an external source, all while implementing basic error handling along the way. So, if you're looking to interact with any RESTful services, just remember that Feign client is your best friend. In our next lesson, we'll venture into testing our error handling mechanisms to make sure everything works as expected. Thank you for joining me today, and I look forward to our next session together.